So thank you for joining us. Today's topic is going to be meaningful inspection data categories for structures and assets. We're going to be looking at a couple of different things in today's presentation. We're going to start with a little introduction to PCTE, Screening Eagle, who make the Inspect software system I'll be using for the examples. We're going to cover the idea of structured versus unstructured data. You may have seen this mentioned if you've attended a Screening Eagle webinar on the topic before, but I'm going to go into a little bit more detail about what we mean, what is a point of structured data, what isn't structured data, and how each can be used, because it's not good and bad. Structured isn't necessarily good, unstructured isn't necessarily bad, they're for different purposes. I'm going to talk about classifications and properties. This is a bit more about how we define what something is. So that's interesting. Better I explain it when I get there. Now, I do sometimes like to talk these down, so I do get to look a bit about what terrible data is, data that's really painful to work with or can be quite unclear in the future. So we'll talk a bit about terrible data. And it's always worth considering complexity, because when you get really clever tools that let you build up large databases of information, you can get complexity very easily. So we'll discuss a little bit about that. I'm then going to just borrow a few notes from Screening Eagle's presentations on visual inspection data versus the sort of data you can get with an NDT sensor, just to contrast that. And I'm also going to use the framing of concrete vital statistics collected with NDT for our case study. So we'll quickly dive sideways to look at that. And if you want more detail, I know Screening Eagle has a recorded webinar that goes into a great more detail about the kind of inspection data you can collect for concrete structures and their philosophy there. So just to further talk about us, PCTE has been around since 2004, founded by Frank Papworth and Ruben Barnes. And we're suppliers to the construction and inspection and NDT industry. We're particularly proud of the, one second. We're particularly proud of the work that we can do with knowing about what we sell. We're not just suppliers who have a catalog of systems we offer. We like to think we understand the tools, how they should be used, and can act as sort of a backing of knowledge to your business. We'll never understand better than you what you're doing, but hopefully we can help you understand the products we supply as well as we do. Screening Eagle are one of our major suppliers. They're a merger of ProSec and DreamLab. And in particular, they're a very software-focused company. So they're always thinking about things like what data is and how to make the best use of it. Example today from Screening Eagle Inspect, but there's lots of other software tools. They offer all of the applications for the live series of ProSec products, workspace, data management for the same products. They now are the owners and supplier of GPR Slice, and there's always more to come from this. That's sort of the context of the supply for the software we're discussing today. In particular, we're going to start with some basic data analysis concepts, and then how we can use that for concrete. And Jun, my colleague in New Zealand, is going to be presenting a case study of setting up a template. So we'll see sort of what we discuss in theory presented in practice today. Now, there's a few things that this presentation really doesn't cover. I'm not part of an inspection company. I don't train inspectors, and we've only got about an hour together today. That makes it very difficult for me to act as a trainer in how to inspect something, what's important, what the standards or criteria from your clients might be, something like a structure inspection manual from transport and main roads. I can't teach you that. That's going well beyond the scope of today. I'm also not advising on what best practice is. I'm offering food for thought. I'm giving you something you can consider in your decision about what best practice is. Also, the kind of tools we're discussing today and the kind of data shaping that we consider is going to be relevant for other kinds of asset inspection, for dilapidation surveys, for managing oil and gas assets, or for just a pretty broad range of tools. But I'm not going to speak in detail about that. That's not what I do every day, but doesn't mean this isn't something you can consider as part of how you might use the tools we discuss or the data concepts we discuss. Okay, so let's begin with classifications versus properties. Just to quickly explain, a classification is a hierarchy, whereas a property is something more like a point of data or something that an incident of a class, so that would be one of the points in a classification, has. I've got lots of examples, so I'll take you through them. I'll show you the differences between the two. But the reason classifications are important is that's how we can create a create a sort of definition of what something is. Is it a building? Is it a bridge? If it's a building, what kind of building is it? What features does it have? So you'll see classifications everywhere. Probably the most common and most thorough classification is simply classifying plants and animals. Is it a plant? Is it an animal? If it's an animal, is it a mammal? If it's a mammal, is it a canine? If it's a canine, is it a wolf? We can see from that there's a couple of key points. That's a parent and child relationship. Sometimes you can have multiple parents. That would be termed ontology. That's less relevant to what we're talking about today. But if you just sort of bear in mind, when we're talking about classifications, we're talking about that hierarchical wolf, canine, mammal, animal sort of classification. And when you're building up your own classification schemes, that's how they should be thought about and constructed. Now, a particular class might have multiple properties. So you could have a wolf could have 4 legs and a head. It could have a wolf could also have eyes. We could measure the length of the fur on the wolf and store the property of fur length against the class wolf. So properties tends to be where we put our measurement data. It's also where we can put sort of something about a class. So classifications and properties is basically going to be different kinds of data points we might add into a form or an Excel sheet or a Screening Eagle inspection spot that we're building up. All right, clear as mud. So let's go look at some examples. This is a fairly straightforward classification scheme defining a structural element. So the classification scheme itself is structural element. Then we have the element type, a soffit, a column, a wall. We have a subclass of a surface wall or a subsurface wall, and then a further subsurface of a metal surface wall or a concrete surface wall. So we've got that hierarchical relationship. This is maybe not the best example. We could argue whether surface or subsurface could be used as a property, but it's, again, just a visual representation of that class structure. Subclass, subclass, major class. Similarly, now let's look at a property instead, where we have some data for dry film thickness measurements. This would be a measurement of the thickness of a coating on a material. And we've got the dry film thickness, and we're capturing specified dry film thickness as the first property. So that's what's expected to be there. And a measured average dry film thickness. So that's what we've actually got there. Useful bit of information. If we know how thick it should be and it's not that thick, we're not compliant. And we can extract that straight from this information. We don't need to have the inspector write compliant or non-compliant, because we can compare the numerical data specified to average automatically. So this is the kind of thinking we're starting to do when we set up what data we collect, what information needs to be there, and how are we going to be able to use that and maybe automate the output from the process. So that's an example of a property. To reiterate, and just to show a quick example, I'll have Jun go in and we'll make up that wolf property in Screening Eagle. So Jun, if you could share your screen, I'll give you access in 1 second. And we'll just see how we go about defining a classification scheme in Screening Eagle Inspect. So this is a standard template. We've got lots of different kind of data here. We've got a single or multiple choice sort of data fields. And we're going to add a new data field. We're going to use a multi-level selection to make a classification scheme. And in that classification scheme, let's start with the top level, which is going to be animal. And let's have wolf and let's have canine and feline. So we're going to then add in a new option for canine and a new option for feline. Very good. Okay, then our subclass for canine can be dog or wolf. So just we'll define that second level title as subclass. And we'll have the options as dog or wolf. June, are you still there?
Yes, I am.
So we sort of pause on the dog or wolf categories. Yep. So
was it double wolf?
No, dog or wolf. So you want a dog or a wolf as the subcategories of canine.
Oh, okay.
Like
that?
I think we're doing a comedy routine. I'm not sure who's on first. Sorry, I'm doing the animal type canine and then a dog or a wolf. And then we've got the second option as wolf. Thanks so much, John. Now, if we do the feline, or F9, and I guess we could do tiger or cat, or house cat. So, see, just we're specifying a master class, and we're doing subclasses to that class. So, thank you. I'll close up the share now just to show creating a classification and inspect. Okay, thank you very much. And we'll keep going and we'll take a look at structured versus unstructured data. Now, this one's actually very important because this is where we go from just collecting inspection data for humans to use to making our life so much easier. We want to do sort of fairly standard data analysis like sorting or filtering or indexing data, and also where we prepare data sets to work with machine learning, artificial intelligence tools, or just start to work sort of more smartly with what we're taking in. So unstructured data is essentially data that isn't ready for a computer to work with. It's something which hasn't been coded or categorized. So if we've got a raw text field and someone can write in severe evidence of corrosion, expect 9 years of life happening there, then that might be a text field, but it's not structured data. We'd need to code that as something like a multiple choice, which lets us so select corrosion and maybe a numeric data point that would go expected remaining life 3 years. Photographic data is, we collect a lot of visual inspection data, lots and lots of pictures of structures, informative to a human, but we need a coded description for that to be something we can look up and sort and deal with quickly. Now, not to say that the computer can't help us with unstructured data. There's whole fields of data analysis and data science that deal with the correct automated coding of data. There's a lot of machine vision tools that will attempt to identify things with different confidence intervals. We actually have tools like this built into Inspect where they can determine what in a picture is a crack. So if you're doing crack mapping, there's less sketching on the wall with pencils. Also sketches by hand and sensor data. For the purpose of what we're discussing today, I'll call sensor data and the exported data from the sensors to be unstructured. That's not quite true. We can actually open it up in other software and work with it. But if we're just putting points of numerical or text data into a database, it's unstructured for that purpose. Also, we're probably going to have some form of external reports. We might have third-party contractors coming and doing all sorts of measurements. We might have NDT inspectors come past and do metal thickness measurement or weld testing. So that'd be another form of unstructured data that we could have in our, we could be dealing with for an inspection. So let's talk about what structured data could be. Photographic metadata and tags, you're probably pretty familiar with the idea. When someone takes a photograph, it's got a location, it's got maybe the camera it was taken with, some information on the lens type. That's an example of structured data that comes along with most pictures coming straight out of the camera. Tags, if you've ever used tag sorting systems to help manage your music, say, you tag your favorites, or quiet ones or loud ones. Sorry, 1 second. I do apologize. I'll continue once the phone stops ringing. Okay. So a tag is another example of structured data you might be familiar with. Now, for the concept of inspect and inspection data, I'll use single choice or multiple choice lists or numeric data as the primary kind of structured data you prepare and inspect. That's what you're working to have when you finish creating a spot template. So what do I mean by that? Let's look at, I think, the first example. This is a single field for indicating the type of defect we have in a place where we've inspected. We've gone to a column or a wall, we've found some sort of element, and we've said, here is a defect. What type of defect is it? And the structured data in this example is going to be, is it a delamination, a crack, a void, or maybe it's a honeycombing type defect. We've also got some unstructured data we're collecting in this field set because we have an others category. This is a bit of an out you want to avoid giving your inspectors if you're setting up a field for them, is the ability to say, it's none of the above, it's something else. That's fine as sort of a small scale project, but if you want to collect thousands or tens of thousands of data points on lots of different structures, you need to have your multiple choice list for things like this finalized so that you don't have one person entering dampness, another person entering water, a third person entering moisture, because we've suddenly defined the same bit of structured data, which we could call moisture, by 3 different words. So watch out for the others category. It's a useful tool, especially early on where maybe you haven't finalized your data formats, but you want to move away from having an others section quickly to be able to make the most use of data you're preparing or exporting. The other form of unstructured data, which is more innocent here, is our free text fields. As I said, free text fields are not necessarily evil, but they're very much for the humans. We can describe visual delamination, drumming across 20 centimeters width, 10 centimeters height. And that's fine. A human can read that and go, oh, I understand the size of that delamination. That's great. But what would have been better would be to have a numeric field for width and height, because then I got a data that a machine can ingest as well as the human being able to ingest it. So text fields aren't necessarily a bad thing, but you need to be putting them in only where you want humans to review what's in them. If you want a computer to do it, you need to avoid those free text fields. So let's look at an example from our case study later, where we're actually collecting a particular measurement on a structure, the cover depth. So the cover from the surface of the concrete to the reinforcing steel. And we've done this rather cleverly here in that we've got 3 different kinds of machines. We've got a ground penetrating radar system, we've got a profoscope cover meter, we've also got a generic cover meter. And for each of those, all of them collect a concrete cover depth in millimeters because they can all measure cover. And also the cover meter systems, the profoscope and the cover meter, we've also indicated that we can enter an estimated bar diameter. This is useful because one measurement, rebar cover, by choosing the machine we've used on site, we've captured a little more information. We know the quality of the measurement, so we know if it's a cover meter, it'll probably be within a few millimeters, whereas if it's a radar measurement, maybe 5 to 10 millimeters uncertainty. We've also got that estimate where those of the bar diameter, where the machines can take it. So it's quite a nice implementation of just capturing that structured measurement that we might want to use. For our next example, let's start looking at some of the clever things you can do with inspect. So this is a ground penetrating radar data point. we've actually taken a measurement of a sort of a grid scan where we've got a 3D presentation of multiple layers of reinforcing and the thick. So we could take from this measurement the reinforcing layout over the 2 layers of reinforcing, or the thickness of that structure. It's still unstructured though, because we haven't recorded or exported. So the way that we can take this, very, very comprehensive, very useful information is we can add to its unstructured part categorization. So what are we trying to say with that measurement? And that completes the circle. We've now got ground penetrating radar data stored, and along with it, a class point, which will tell us what it's for, what it means. So if someone's coming back and wants to see all of the evidence on insufficient cover, they'd capture radar scans, cover meter measurements, physical drilling and inspection, all as one point, because we've taken the chance to categorize it. A couple more kinds of data. We've got a picture, a defect, sort of a crack map done with the defect functionality in Screening Eagle Inspect, and a external report from a dry film thickness measurement system. So our picture, again, it's unstructured. We don't know what that represents. We add a category, in this case, leakage. We understand what that picture is evidence for, the source of leakage, which is visible. With our defect map, we know that we've got a representation of a crack map, but we don't know how wide and how long. So we add the width measured optically, the length calculated, and some reference information about how big the picture is. And there we are. We've got a meaningful point of structured data that we can actually process. Look for all crack widths above 0.1 millimeter, for example. So if we don't have this stored, the picture doesn't have meaning to a sorting, processing, filtering, searching function. And again, we've got a lot of different information in here. It is essentially a free text field with bonuses. It's got lots of places to enter points of information. If we it'll import that PDF and extract our dry film expected measurement and the actual measurement. We've now taken that structured information and we've got the evidence in that PDF file to back us up. So that's just recapping unstructured data. That's the sort of things a human can look at it and understand, but a computer can't. The structured data is things which have more information, essentially that we've coded information in. We've chosen criteria like types of defect or type of element, or properties like measurement of thickness, and we've used that to inform our unstructured data. Or we've only collected the structured data in the first place where there's no backing up evidence. Does anyone have any questions on that? Because I feel like I've covered a lot there before I continue to the next stage. Watching the chat and watching for anyone to unmute if they'd like to. Okay, thank you very much. I will keep going. Now, I sort of said that the structured and unstructured data are pretty values neutral. Structured data is not better than unstructured data. It's just used for different purposes. Now I've got to go kick the text boxes in the teeth a little bit, unfortunately. They're a pain. When you've got uncoded free text data, it's so easy to get something that is less useful when you get it onto a computer. I know it's just almost human nature to have a notepad, write down, we saw crack in the wall, it was 10 millimeters wide, it was here, and to sort of describe things that way. But there's so many little things that go wrong with free text fields. You can search them for individual words, but we can't index or sort them because they're too information dense. We can't go show us every description of a crack width because it could be written as crack width. We could infer its crack width by the inspector writing width 2 millimeters, leaving it, or it's 2 millimeters. We leave out the descriptor of it being a crack width. They might not describe what elements it's on. So by making too much use of free text, and in particular, not having structured multiple choice or single choice selection options, you end up with unsearchable, you end up with data that can only be searched, can't be indexed, can't be sorted, can't be sort of broken down by components. You also have the fun of homonyms. I've talked about that So if different words can mean something completely different in the context, so if someone's too brief, the sentence might completely change meaning. And the other thing is you might say, oh, we can fill in the categories when we get it back to the office. Someone can type it up in Excel and take that description of 10 millimeters crack depth and write it in. Well, again, what if they left off the fact it was width of a column this time rather than width of a crack, or width of wire that they noticed was protruding? It's better to code on location. And this gives you the output. You can see on the picture on the right there, where because it's been coded in, because we know we're looking at all of our incidents of spalling, we can bring it up right away with a simple, with sort of a simple filter function. So that's the power. That's why we're doing this. That's why we're taking the extra time. Abbreviations are also a bit of a nightmare. A particular example, I remember I was on LinkedIn watching people argue about, you said it, you used your ground penetrating radar and you found PT. And one person saying, well, you can't just call it PT. It could be post-tensioning or it could be pre-tension tendon, and that's completely different. And then somebody else coming and saying, well, when I say PT, I always mean post-tension. That's because as a radar scanner, that's what I come in to find. And you just get this ongoing sort of nuisance discussion because we didn't break out the full word. It's really helpful just to say exactly what you mean. Again, if you're selecting from a multiple choice list, you don't have to write, you can write more letters. It's not going to take longer. You also get acronyms where people come up with sort of stares and try and make that mean something. It just becomes a bit of a pain. The bad numbers example was from one of the textbooks I was reviewing for this presentation. It's kind of a bit uncomfortable. This comes mainly from the medical industry, where if you miss the decimal point, there can be big problems ahead. So they will absolutely avoid things like going 2.0 milliliters, because if someone misses a decimal point, someone just got 20 milliliters of the medication rather than 2 milliliters. That could be a very big problem. And you get the same problem is if you don't put the 0 before the decimal place. It could just be read 7 rather than 0.7. Again, order of magnitude more medication unintended. So when you are entering numbers, watch out for things like that. I beg your pardon. The final point worth making is a sort of data concept is the concept of a triad. In order to really have a point of information, we need three things. We need a unique identifier, something like just a constantly increasing number like the spot number in inspect, or some other way to sort of have a unique identifier for what that thing is. You need a description of what it is, so a meaningful title. Things like our dry film thickness average is a meaningful title. That's a second point of information. And then we need the actual information. So we need, that would be the measurement of the dry film thickness. If you haven't got these three things, you've sort of got a floating point of information. You don't know what it is, or you don't know which one it is, or you don't know what was measured. So just bear in mind, when you're setting up, these are some considerations to make your structured and unstructured data clear. Finally, let's talk a little bit about complexity. We're setting up an Excel sheet or a spot template. We're going to start out by listing components, category, severity. We'll write down who got it. We'll write down how it's going to be repaired. We'll put some text in so people can describe that in detail. We'll add some codes because we've got a internal coding we use for types of defect, internal coding for severity. Ooh, we need some information on the type as well. It's getting a bit of a, okay. And it just goes on and on and on. This is perhaps the second danger with a system that makes it easy to collect a lot of information, is you sort of do so without thinking. You get everything in the kitchen sink. So sometimes we don't have a choice. This is an example of a structural inspection template from the Netherlands to a Netherlands standard. And it's very comprehensive and it's useful because if you're working to this standard, you've got a clear definition of the information you need to collect. But it does mean we're taking 10 or more data points every time we stop and look at something. So it's going to slow us down a little bit. So in the context of creating our own categories, we can keep it as simple as is possible. Simple points of structured data, the smallest number needed to correctly inform us to make decisions and to be able to post-process and use that data when we get it into a management system. And if we've got an external criteria, a client specification, a standard we're following, it's fine. We'll collect everything we've been asked to collect. Maybe we add 1 or 2 points that help clarify that. But then we should simplify at the exporting stage. We should make sure that if the remarks and the remaining expected service life don't need to be analyzed in what we want to do on the computer, we don't need to pull it out of that data set when we're working with it. So either prepare very tight specifications or collect a little more data and trim it down at the stage of analysis. So that's the completion of the data concepts I want to discuss. Is there anything anyone has questions on, comments they'd like to add before we start looking at a case study of how we might apply this? All right, thank you very much. I will keep going. So I've borrowed the next couple of slides from Authentic Screening Eagle just to sort of convey some of the inspection data we might want to collect visually, take notes on, and get from our NDT test equipment. So we, surface defects just visually found, cracks, maybe some sort of depth measurement with ultrasound. We can use thickness measurements with NDT tools. We can do rebar depth with several tools. And maybe we're looking for voiding or object location as well. All that's something we might want to capture as part of an inspection. For the case of the particular case study, I'm going to go down to the vital signs. So the context I'm going to talk about here is if we want to capture and store NDT data for vital signs, what is a way we might choose to go about it? This is not best practice for this. This is my view of how I'm going to take this vital signs concept where we want defects and thickness location, strength and homogeneity, and rebar depth of a structure to be stored in a data category. So we'll use inspect as our management tool. We'll have different kinds of NDT systems we can use to work that up. And let's go look at creating that. So first step, what am I going to record by? I don't really want to record by machine because if I take it profoscope measurement, maybe I'm getting one kind of information. If I take GPR measurements, I'm going to be getting a different kind of information. So instead, let's actually go by the type of vital signs, so defects and thickness, or strength, homogeneity and thickness, or concrete strength and uniformity. That's what we're going to choose as our main class, or maybe to work with. Then we're going to set up, in this case, this is a spot template where we've defined type of element, then we've got concrete strength, which we can capture with different instruments, rebar cover, thickness. So we've got all, and we can choose one or more of these per position to store. A lot of these are optional because there's no point making it compulsory to collect the rebar cover everywhere because there may be no reinforcing in that region. We maybe don't want to collect concrete strength because we're not sampling strength in that area, or we've got other records. So secondly, we're going to make a spot template up, include the data from the equipment, and we can import PDF files or other exports from systems that don't have a direct path across. All of the live products from Screening Eagle ProSec are going to be importing pretty directly, or will be in the future, but you've got simple cover meter exports and other tools that we can bring in manually as well. So in this example, structured data, dry film thickness, we've looked at this before. And in this example, if we're taking thickness measurements, collect values in thickness. If we're finding something a bit more abstract, like a delamination, we can use our free text field because we want a little bit more information. So when the human inspector looks at all the delamination type defects, they can learn a bit more about it, but it's not going to be as quantified as that thickness measurement of the structure. Okay, June, I'll hand over to you again to load up and show how this looks in the back end of Inspect.
Cool. Thanks, William. Yep. So this is the Inspect app where you have all your asset, and if you click into the asset, you can create a spot template where we just discussed. And I've made this kind of a default template for vital signs to classify the type of defects or the type of inspection that you want to do. Say we have a concrete strength, cover, rebar spacings, and diameter. And in each of this, we have different equipment to do the job. And on that, you can put in number or text to give you some context of what are this measurement all about. And these are the single selections where you choose which equipment you want to do for that particular inspections or defects. And these are the multiple selections. You can have different defects on the same spot or on the same job. So you can select this and put some notes in where you have collected data and give you some context as well. And all these classifications, all these elements are optional. I've made it optional instead of mandatory. So if I click in here and you see this, there's no sign that I can, there's a bin here that I can delete where it shows it's optional. If it's compulsory or mandatory, like the severity and the reporter, it is compulsory, you see a star. So this means I have to fill up this section to complete the template or to generate a report. And the rest is all mandatory. And at the end of the template, you can have a remark, say a conclusions or a summary of your inspection project. It gives you some context or a note for the next person or your team members to continue the job. And just a quick demo on what we did just for the multi-level selections. You can add in here, say, for example, I can name this structure element. And say I can name that as a slab. And on the second level or the subclass, or this is the third subclass. I can say, for example, this is a suspended slab or a breach. And on the suspenders that I can also add the third category subclass, say it is a post tension or a pre-tension, for example. So this is the template that you can create before you go on the job. And once you created the template, just save and publish that, and you can perform the inspections on site.
So do you have an example of a spot in action on the dashboard, maybe, just to show what a spot would contain? So the whole concept here is we're doing the pre-work to set up our final tools we're going to use on site. So now we've got the dashboard, and this is where all of our work comes into effect. So we've got up at the top left there, we can sort or filter by category or component. So this lets us see all of the spots, whether they're actually representative of a defect or just informative, and we can look at particular types. So we can choose all of the columns and see what's happening with our columns. And if we click on any of those columns, we're actually going to get the measurement information from that. So this is the structure of the system. Now, do you have a example of a location map for me? So a 2D view, please. We'll just have to show the example of one from where we imported them. So yeah, so the floor plan in 2D, please. So the final step is all of these spots have been given location. We've placed them on a 2D view. So if we're looking at a column, we can see on our plan which column it's on. We can sort and filter to find which columns are troubled. And it's a sort of permanent single source of truth for the asset owner. They come in and they can see the current state of their asset. Or if we're just using this to improve our inspection workflow, we can immediately see where we've been, what we've done, what we haven't done. We can export all of that information that we've taken the time to set up straight into a data format that would represent what the client wants. It just lets us work more quickly, more effectively. We can document and prepare on site. We don't need to come back to the office and spend 10 hours re-entering things in Excel or doing too much rework, because if we take the time ahead of time, it'll be coming out in the format we want it to work with at the end. I'll finish up the share now for the moment, Jun, and I'm sure we'll be talking more about this in the new year, where we start to go through some examples of collecting this information, and also where I'll go through some examples of finalizing that information and doing an export. But I wanted to start right at the beginning, where we consider how we choose what information we care about, and considerations that are going to make it easier to work with it on a computer, not just as a human being, not as the inspector or the engineer. We want to make it so our machine can help us out. Thank you very much for coming along today. That's the conclusion of the presentation. Again, I'll stay on for a few more questions, or if anyone's got any comments, points they'd like to make, or just have a natter before we finish up. But thank you very much.